Okay, this is one version of problem number 19 from the WebAssign problems in chapter 1, section 3, excuse me. We're to find the value of sine of theta and tangent of theta if the terminal side of theta lies along the line y equals negative 7x in quadrant 2. What we need to do here, what we need to think about, is we need to find a point on that line y equals negative 7x, and we want to make sure that that point is in quadrant 2. Well, in quadrant 2, all of the x values will be negative. So let's pick a negative number to put in place of x. So how about x equals negative 1? So so we have an angle theta. That angle terminates in quadrant 2, and the terminal side of the angle coincides with the line y equal negative 7x. So let's think about this. We have y equal negative 7x is a line that looks about like that. It's actually a little steeper than that, but we're looking for some point on the terminal side of that angle that falls inside quadrant 2. So let's pick an x value, a number to plug in place of that x. We want to make sure that our point is inside quadrant 2, so we know that all x values for all points in quadrant 2 have to be negative. So let's pick a negative number. So let's let x be equal to negative 1. If we replace x in our equation with a negative 1, we'll find out that a point that satisfies this condition would be negative 1, comma, positive 7. So the point negative 1, comma, 7 lies on the terminal side of this angle theta. So negative 1, 7 is on the terminal side of theta. So we also know that r is equal to the square root of x squared plus y squared. So our x and our y are negative 1 and 7. So if we do the arithmetic there, when we square negative 1, we get positive 1. When we square 7, we get 49. 1 plus 49 is 50. So r is equal to the square root of 50, which, since 50 is 25 times 2, and 25, of course, is a perfect square, we get, in a simpler form, square root 25 times square root 2, which then can be simplified to 5 square roots of 2. So that's our value of r. So we know that the sine of theta, by definition number 1, is equal to y over r. So our y value is 7, our r is 5 square root of 2, so y over r would be 7 over 5 square root 2. Now if we want to rationalize that denominator, we would multiply by a well-chosen 1, square root 2 over square root 2, which will give us 7 square root 2 over, when you multiply square root of 2 times square root of 2, that makes 2 times the 5 makes 10. So sine of theta, rationalizing the denominator, would be equal to 7 square root of 2 over 10. The tangent of theta, which was the other function value we were asked for in this problem, tangent of theta, according to definition 1, is y over x. Well, that's a little bit easier. We don't have the square root in there to mess with. So y divided by x, and our point would be 7 divided by negative 1, and that simplifies into negative 7.